Hello, today we will be talking about solving inequalities by addition and subtraction. Before we begin that, we need to know what an inequality is. An inequality is an open sentence that contains our inequality symbols. So let's write that down for us. We have an inequality. And basically, it is just like an equation, an open sentence. The difference here is that it contains inequality symbols rather than just an equation. So we have less than, greater than, less than or equal to, greater than or equal to. And we learned these in about 6th grade. Hopefully we remember what they are. Less than or equal to. And greater than or equal to. Okay. The second thing we need to know, and this might be new to us, is a set builder notation. This is how we write our solution to an inequality statement. So, set builder notation. It's going to look like an teacher squiggle, X, or whatever variable is written in the problem with our bar, and then the inequality statement that makes the open sentence true. So if we have X greater than 5, close teacher squiggle. Now, so the way that you read this is kind of important. You read it as the set of all numbers, X. So this is our X. That's the set of all numbers. In our case, we have the variable X. If it were a different variable like M or Y or Z, you would use that variable instead. Okay, and then such that, that's what this bar represents, such that. And then you finish by reading the inequality that makes it true. So your final thing. So this is such that X is greater than 5. And you stop there. So that's how we read our solution and write it in set builder notation. This set builder notation comes in handy when you're graphing because you don't have to write out the entire thing. You know exactly what it's talking about. All right, so let's move on and look at solving by addition. Let's change our color here. Let's go to green. Okay. So we have solving by addition is what we're going to move on to. Okay, so solving by addition, basically the same rules apply as when we use inverse operations solving with variables. If the same number is added to each side of a true inequality, the inequality remains true. So if the same number is added to each side of an inequality, then the inequality remains true. All right, so let's look at our first example. Example 1. we're going to solve x minus 12 is greater than or equal to 8. So the way that this looks, if we ignore our inequality symbol, you could solve this by adding 12. Well, the same thing applies here. We are simply going to add 12 to both sides of our inequality. When we do that, we have x, keep the same symbol, greater than or equal to 8 plus 12 gives us 20. So we would write the solution to this in our standard form, looking back, set builder notation. We want our solution to look like that. So we have a set of all numbers x, such that x is greater than or equal to 20. And make sure you put your little teacher squiggles around it. Now, if that is our solution, we need to check it, and you can check by doing 3 things. You want to choose a number that is larger, smaller, and then the number itself that we have. So let's check our work. And let's choose x to be 20, x to be 30, and lower, let's choose 10. So if I have 20 minus 12 greater than or equal to 8, that gives me 8 is greater than or equal to 8, which is true. If I use 30, I have 30 minus 12 greater than or equal to 8. 30 minus 12 gives me 18. 18 is in fact greater than 8, so that is also true. Now if I do 10, I have 10 minus 12 is greater than or equal to 8. 10 minus 12 gives me negative 2, which is not greater than or equal to 8, so that is a false statement. Therefore, if I go back to my solution, it says that x has to be greater than or equal to 20. And 20 and 30 both checked out. They were true, and 10 did not, which is also true with our solution. It should not have satisfied that equation, and it didn't. All right, let's move on and look at example 2. Change our color back again. All right, so example 2 for addition. We have solve 22 greater than m minus 8. So what we're going to do here is subtract 8 from both sides. Or not subtract, add. My bad, we have minus 8, so we're going to add 8 to both sides here. And I get 22 plus 8 to be 30 greater than m. So my solution set, remember we need to go back and write it as a set builder notation here. So that set builder notation again is going to help us later when we need to graph this answer. So we write our solution as all numbers m such that m is less than 30. So here, notice that right here we have 30 greater than m. If you flip that, because we need our variable to come first, you flip the sign so that m is less than 30, which is still true. Before, when we switched the x with the number, you didn't have to change the sign. But here, we do change our symbol so that it stays true. Now, let's check our work just like we did before, just to make sure. Let's choose x equals 30 x equals 20, and x equals 40. With those values, let's plug them into, oh, I used x. We don't have x. We have m. So let's fix that here. Notice that that's a mistake that's okay to make sometimes. Variables are interchangeable. Right now we only have one variable, so as long as you know what you're talking about, you're good. But for further investigation, if we had more than one variable, like we did when we were solving multi-step and multivariable equations, we need to make sure we keep a consistent variable here. So let's change that to m. So when we substitute the values in for m, we get 22 is greater than 30 minus 8. 30 minus 8 is 22. So I have 22 is greater than 22. Is 22 greater than 22? No, it is the same as 22. So that does not work. So that is false, which satisfies, if you check our solution, it says that m has to be less than 30, so 30 shouldn't work, and it doesn't. So if we do 20, we have 22 greater than 20 minus 8, and 20 minus 8 gives us 12. 22 is greater than 12, so that one is true. And if we choose 40 to be our m, we have 22 greater than 40 minus 8, and 40 minus 8 is 32. 22 is not greater than 32, so that is false. And if we look back at what we checked, the only solution that was true was one that was less than 30, which is what our solution set says, that it has to be less than 30. Okay, so what I want you to do now is practice some of these problems on your own. So I want you to pause this after I write down the practice problems, and I want you to put these in your practice notebook and work on your own. We will check these tomorrow in class at the beginning. So your first one is x minus 3 is greater than 7. And your second problem here is 10 greater than n minus 1. So practice these on your own. And make sure you bring these to class tomorrow.